So we talked about what radioactivity is, the different sorts of particles and emissions. How do we detect radioactivity? We detect the particles emitted by radioactive nuclei by looking at their interactions with atoms or molecules. So one way of detecting radiation is called a thermoluminescent dosimeter. And a dosimeter measures radiation over a period of time. And so these are used to monitor the exposure of a person who's working with radioactivity. So here we have the photograph of the dosimeter. It's a badge that's worn on your lab coat, and it is exposed to whatever radioactivity that you are. So it would have a salt in it, such as calcium fluoride, that's excited by ionizing radiation. Those excited electrons are trapped by impurities that are intentionally put into the crystal, and when that crystal is heated, it will emit light that's proportional to the radiation exposure. So the crystal in that dosimeter is trapping excited electrons, and then after a certain period of time, the person would turn the badge in, the badge would be heated, and the light emitted would be analyzed. So you can monitor how much radioactivity a person's been exposed to. That's not very useful in terms of we need to know right now, because that's going to occur over the course of weeks or months. A Geiger counter measures radioactivity in real time. And this is what you stereotypically think of when you think of detecting radiation. So some of them do take the form of the little box that you hold in your hand, and you've got this wand, and it can be set to go click, 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 click when it detects radiation. So what's happening here is we have an argon-filled tube, a chamber here, and as radioactive particles pass through that chamber, they ionize the argon atoms, creating a trail of ionized argon atoms. We apply a high voltage across the tube, which without the ions would not conduct electricity, and so we get an electrical signal for each particle that goes through, because it ionizes and allows current to flow. So it can be displayed on a meter, it can be digital or analog. This is an analog meter. And you can also set that to trigger a sound generating device. You can get an audible click. And so that's what you see in the movies, where they're getting closer and it goes click, 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 and then they move away and the clicking slows down, right? That's the Geiger counter. A scintillation detector also measures radioactivity in real time. Here you have the radioactivity passing through a material. It's often sodium iodide or cesium iodide, kind of like the the calcium fluoride. It emits UV or visible light in response to excitation by these energetic particles of ionizing radiation. So then you detect the light and turn that into an electrical signal, which can be read on a meter. So again, we're looking at how the radioactive emissions interact with ions or molecules. Any questions?